Okay, this is question 9, 10 and 11 from exercise 13G. It's the integration area between two lines, between two equations. I can't remember the exact wording of it. But I'm just going to go through question 9, 10 and 11. Question 10 I think is quite a good one. So it's definitely worth watching that. Okay. So, hopefully you've got some understanding of this concept, because I'm not going to kind of teach it from the beginning. If you're watching this video, this means you've done well at kind of the basic questions and you're just getting a little bit stuck on the really challenging ones at the end. So we've got two lines here, and we want to find in part B this area in the middle. Part A is just asking us to verify if the lines cross at this point. Basically, if we sub in 4x is 4 for both of them, so let's do that. We'll get equation 1. And we've got equation 2. So if we take the x coordinate of this, so let's say x equals 4, if we sub that in and get y equals 2 for both of them, well then we know that 4, 2 is a coordinate in both. And if they share a coordinate, they must intercept to that coordinate. So that is good enough to kind of verify this. So let's go y equals 2, 3 lots of the square root of 4 minus the square root of 4 cubed plus 4. That equals to 3 times 2 is 6. 4 cubed is 64, square rooted is 8. Add 4. 6 minus 8 is minus 2, plus 4 is 2. So this one has a coordinate of 4, 2. So that works. So let's go for this. Y equals 4 minus a half lots of 4. That's 4 minus 2. That is 2. And then we need a little line at the bottom saying both have the coordinate 4, 2, therefore intersect with an S at 4, 2. And I'm pretty sure that's exactly how I would do it. That's good enough to get that part done. Find the area of the finite region. So I'm probably going to need this again. So let's get this down here. So find the area of the finite region. If we do this, so the integral, so we know the x coordinate here, by the way, is 4, don't we, from this coordinate. So we're going to be integrating between 4 and 0. If we integrate between 4 and 0 of my black curve on here, which is this, in green, I'm actually going to be finding all of this, aren't I? I'm going to be finding all of that, which is far too much. So I'm going to have to, dx, I'm going to have to take away the integration of what I'm going to do in blue, which is the integration of if I do the straight line, so 4 minus a half x dx, which is going to be what this blue is here. So if I take what I found in green and subtract what I found in blue, it's just going to leave me with what I'm going to mark in red. And that's kind of what we do, and that's why we do this. I like to do it all at once, so I kind of do these both at the same time. I know some people like to just take this, do it, take that, do it, and then subtract them at the end. I'm going to do it that way actually, because I think you'll be more comfortable with it. So I'm going to do them separately. But if I was doing this myself, I kind of just work. I work this all the way down and do both at the same time. I don't find it that much harder. But let's do So R meaning the region equals this. So it's good to say what you're finding. I'm just going to do this first. So this step. First of all, I need to get this into a form that I can work with. So square root of x is power of a half. Cubing it and square rooting it, that's the power of 3 over 2. Okay, and then I'm going to integrate it now, so I'm going to get rid of my integral sign, and I'm going to add my squared brackets, because that kind of shows that's the way I denote it. I've integrated it now, and but I still need to check the limit. I still need to do it between the boundaries to find the definite integral. So raise the power times by the power, or divide by the power, sorry. So I'm just going to get my solutions up from before, so I'm not spending ages doing loads of fraction work in front of you. So 3x to the power of a half divided by 3 over 2. X to the power of 5 over 2 divided by 5 over 2. 4x plus c. And that is between 4 and 0. That equals to 2x to the power of 3 over 2, sorry, minus 2 over 5x to the power of 5 over 2, and then plus 4x plus c, and that is still between 4 and 0. Okay, so substituting in 4 into this. If I go through and substitute 4 into all of that, I am going to get 96 over 5 plus c. And then if I substitute 0 into all of this, I'm going to get 0 plus c. My plus c's cancel. I know it's pointless doing that, but you just have to for mathematical correctness. So 96 over 5. So I'm just going to put that to one side for a moment, and I'm going to, in a different colour, do this step. And I'm going to do that up here, I think. So integrate this between 4 and 0. So that 96 over 5 is what I originally shaded in green. It's all of that big area there that I shaded in green in my diagram. So integrating this, I'm going to get 4x minus a quarter x squared plus c, and that's between 4 and 0. So substituting in my value of 4, I get 12 plus c, and then substituting in my value of 0, I get 0 plus c. They cancel out, so we get 12 for this. But we need to do this, subtract this, so my final answer for my region R is 96 over 5, subtract 12, which is 36 over 5, or 7.2 on the dot, or 7 and what, 1/5. So that's that question. Okay, I liked this next one. Get him set up. I'm going to make him bigger because I'm going to do a bit of a explanation at the start, then I'll minimize him. So before I even have a go at these questions, I just go ahead and do what I know. So I'm going to expand this because I know I need that expanded to start doing any work with it. I can't integrate from these brackets yet. These areas are equal, so that's helpful. And it wants me to find the area of R1. So this right side looks confusing, but thankfully for A, we don't need to bother with that bit yet. So we know that because of this, it's got x-intercepts of 0 and 4, minus 4, sorry. So this is going to be minus 4, and obviously it's on the origin, that's going to be 0. So that's what I'm going to be integrating between. So I'm going to be integrating between 0 and minus 4 of my equation x cubed plus 4x squared. When I integrate that, I am going to get a quarter x to the 4 plus 4 over 3x to the 3 plus c, and that is between 0 minus 4. When I substitute in my value of 0, I obviously will get 0 plus c. And when I substitute in my value of minus 4, I'm going to get minus 64 over 3 plus c. The c's cancelled. These two negatives here, always be careful with that. That's going to actually turn it into a positive 64 over 3, which makes sense. We want a positive area for R1. So that is 64 over 3. It wants us to find the value of b for part b. How we're going to do that is, well, if we integrate, I'm going to get a different colour for this, if we integrate the function between 0 and we know that this is 2, we're going to find what I'm shading in green. So we can do that through integration, but we can't particularly do anything for this bit on the right for integration. But if you realise that when we just drop a straight line down, we've actually just made a triangle. So I've actually just made this triangle, which I'll draw out again here a little bit bigger. This triangle's got a height of 24. We're going between b and 2. Just think about it in your head. If that was 5, if b was 5 and that was 2, we would do 5 take away 2 to find this length. So this length here actually is b subtract 2. That is that length. To find the area of that, well, we're going to do base times height divided by 2. And then if we add that on to what we get from the integration, that will be the full area of this blue thing. That will be the area of what we've just found on the yellow, because they're equal to each other, like it said in the question. So because R1 equals to R2, I know that 64 over 3, which is what we just found before R1, equals to the integration, or the definite integral, between 0 and 2 of my cubic function, plus the area of the triangle, which is this thing here. So hopefully you followed along with that. If not, give it a rewind and see where I've just listened to me again going through it. It's a really tricky thing to always look out for triangles and trapeziums in these questions, but if you're ever completely stuck and you feel like you just can't integrate things, or if lines go off on a kind of a sideways like this, that's generally when you've got to look at kind of doing some integration and some basic area knowledge. So let's go ahead for this. I'm just going to redraw my triangle out again, just because I think it's going to be helpful to me. Woo, that was exciting. So b minus 2, 24. The area of this triangle is going to be 24 lots of b minus 2 over 2, so 12 b minus 2, so 12b minus 24. Just going to keep that as an aside. I can chuck that straight in when I need to. So actually, just to keep it nice and neat, I'm going to do this. I'm going to do this first, and then I'm going to put it all back together. So I've got one, I'll get my second one, and I've done my third piece. I'm going to put it all back together just so it looks a bit neater. We've already integrated this, thankfully, so we don't have to do that all again. Not that it would have taken you too long, but this is it. When we substitute in a value of 2, we are going to get 44 over 3. And when we substitute in a value of 0, we'll get 0. The c's will cancel out. I'm just going to leave it like that. We know it's just going to stay like that. So, put a little circle around that, put a little circle around that, put a little circle around that. I'm going to put it all back together. So 64 over 3 equals to 44 over 3 plus 12b minus 24. Let's do some rearranging. Subtract the 44 over 3, add the 24. We are going to get 12b equals to 92 over 3. Divide by 12, I'm going to get b equals to 23 over 9 or we could say that that is 2 and 5/9. Go back up to your diagram to just double check that that value makes some sense. So 2 and 5/9, yeah, it's going to have to be bigger than 2. If you've got value less than 2, you're definitely wrong. And judging on the scale, they're never drawn to scale, are they? But they're not. They're roughly. It's not like this is going to be 1,000 or something. It's going to be roughly between 2 and 4. So yeah, I would say, judging off that, that's a pretty sensible answer, and I'm happy with that. And I know it's correct because I've checked in the book. But that's kind of the check you can do when you don't know if it's straight away the correct answer. And this final question, some exam hand problem solving, 11 marks this. So if you get this done, you're doing quite well in the test for sure. But this is really, really hard. So find the coordinates of A and B. That is going to be where they intersect. So I'm just going to make them equal to each other. So I'm going to make this equal to this. So 10 minus x equals to 2x squared minus 5x plus 4. I'm going to make it equal to 0 so I can factorize and solve it and find the 2x values. So when I do that, 2x squared minus 4x minus 6, I'm going to divide by 2 to make it easier to factorize. It's fine to do that. It's not fine to divide by x's. You have to factorize them out, but dividing by numbers is fine. And then when I factorize that, x minus 3, x plus 1, so therefore x equals to 3, x equals to minus 1. Substitute these into either equation. I'm obviously going to pick the much easier one. You can double check and sub it into the other one, you'll get exactly the same values, you'll just be wasting your time. So x equals 3, that's 10 take away 3, y equals to 7, so we've got a coordinate of 3, 7. And with x equals to minus 1, 10, subtract minus 1, that's going to be 10 add 1, y equals 11. Next you just need to figure out which is which. Well, obviously the minus 1 is A, and the one with the positive x value is B. Yep. So we've got our coordinates. Now time for part B, which I'll do in a different colour in case they get close to each other. Find the exact area of R. So if I integrate this straight line between my values of 3 and minus 1, I'm going to find all of this red, aren't I? So if I do the integral of 10 minus x between 3 minus 1, that's going to give me my red. And then if I integrate this curve between 3 and minus 1, I'm going to find that blue. And if I take that away, I'll just be left with what I'm going to go over in green, which is what I want. So I'm going to do the straight line into definite integral, subtract the quadratic one. I've never experimented enough whether if I do it the other way around, do I just get the same answer but negative? But I've always I always think it's best to stop and think about which one you want to put first, which one's going to cover more area. I guess you could figure both of them out and then do the bigger one, subtract the smaller one, to eliminate any of that decision making, but I don't find it too hard from looking at the diagram. So subtract the integral between minus 1 and 3 of 2x squared minus 5x plus 4 dx. I mean, yeah, like, let's say this is 5 and this is 2, that would be 3, but if you did 2 and 5 you'd get minus 3. You would just get the same answer but negative. So it's not too much of a problem if you've got a bit of brains on your shoulders and you can figure out what your final answer should be like. But it's nice to just get it right first time. So let's do the red in red and let's do the blue in blue, eh? So let me integrate this guy. Get my solutions up just so we can go through this a little bit faster. I don't think you need to see me integrate, sub in numbers. Okay, that's that. So once we go through all of this, I am going to get 51 over 2 subtract minus 21 over 2, so that's going to get me 36. And then if I go for my blue one, hopefully you can just following along with my colour scheme on this, I'm not setting it out the best to be honest, but if I go for my blue one, when I integrate this, I am going to get 2 over 3x cubed minus 5 over 2x squared plus 4x plus c. When you're doing these things up here, always remember to put your plus c's in there because they will just cancel out. But it's good to write them for practice. You can lose marks otherwise on certain types of questions. So when we do that, substituting our values, we're going to get 15 over 2. That would be a subtract minus. I'm just going to stick it together. So 44 over 3 you would get for your area for this second integral. Let's go ahead and do the final question again. So region R would be 36, which is this, so 36. So I'm just doing that, and that's the reason why. And when I do that, I get 64 over 3, or 21 and a third. So that's them 3 questions. I think question 10 was my favourite. This one was a little bit boring, and the one before was also boring, but question 10 was good fun. Alright, cheers for watching.